the directions here are to factor each and solve. So when it comes to factoring, the first thing we want to see is if our equation has a GCF, where it looks like each of these two terms can be divided by 5 and a single x. So if we divide 5x out, we would have x to the fourth minus 1 equals 0. So GCF is always prime. That can't factor more. But when I look at the x to the fourth minus 1, I see it is a difference of two perfect squares. So x to the fourth would be x squared squared, and 1 would be 1 squared. So I know that that second piece can then factor into the conjugates x squared plus 1, x squared minus 1. So that breaks down into those two. Now when I analyze these factors, the GCF is still prime. The second factor is not a difference, so right away this thing is finished. It's not a difference of squares, so we can't factor that any further. If we look at the third factor, that is a difference, and x squared is x squared, and 1 can be written as 1 squared. So this third factor can be broken down into its two factors, x plus 1, x minus 1. Whenever we reach something linear with just regular x, no exponents, those are automatically prime. Those aren't going to factor anymore. So this would be the factored form of that equation. And then to solve it, we're going to set each factor equal to 0. So 5x equals 0, or we can really just look at the x, because 5 and x are two separate factors. So that means x equals 0. If we look at the x squared plus 1, we'll solve that equation. So x squared would equal negative 1. So x would be plus or minus radical negative 1, which is I. This third factor gives us that x equals negative 1, and the last factor gives us that x equals 1. So those are our 5 solutions. We have that x equals 0, I, negative 1, and 1. So those are the 5 solutions, and we expect that because our degree is 5, and so we should expect to have 5 solutions in the end.